So on my desk I've got two different Ordnance Survey maps. The one on the left I borrowed from school, it's what people use when they do Duke of Edinburgh, and the one on the right I just got off eBay. Now, give or take, they represent roughly the same area, they map roughly the same area. If I show you this one here, it's got Dover and Folkestone, goes up to Canterbury and Ramsgate and so on. So that covers quite a large area. And the other one that people use for Duke of Edinburgh, this one's a bit more zoomed in because this covers Folkestone and Dover, but doesn't go up as far as Canterbury, doesn't go quite as far east either. So you can see the two side by side there. So the pink one that I showed you originally, that's quite zoomed out, and this one's a bit more zoomed in. Now I really want to draw your attention to one particular feature of a map, and these maps in particular, and that's called the scale of the map. You should have heard of that before. This map has a scale of 1 to 50,000, and that can also be written like as a mixture of units as well. And the school map has a similar thing, but that says that the scale is 1 to 25,000. It also has the thing where you can give the scale as a mixture of units. So those two scales side by side. Now this is the pink map, the one that's quite zoomed out, the 1 to 50,000 map, and you'll notice you can get quite a lot of the local area in to quite a small space. And this is the map I borrowed from school, the 1 to 25,000 map, and I'm holding my phone about the same distance away from the map as before, and you'll see that it's a lot more zoomed in. I'm not holding this any closer than before. No, I did do a little zoom out before, but there we go. This is actually taking up nearly all of my desk in order to get Folkestone and Hythe in. I'll try to put them side by side again. Okay, so pink map up here, hanging down where that's Folkestone and Hythe, whereas down here that's Folkestone, that's Hythe on the 1 to 25,000 map. So it's much more zoomed in on the school map than on my one, which is more zoomed out. So on my pink map, it said that the scale was 2 centimeters represents 1 kilometer. So 2 centimeters on the map is actually is how we represent what is a kilometer in the real world. It also gave the scale like this, 1 to 50,000, and I'll explain that version a little bit later. But we'll start with this one. This one's a little bit easier. Despite the fact that it's got a mixture of units, it's actually normally the easier version. Now, on my map, I measured the distance between Folkestone and Hythe, and on my map it was 13 centimeters. So I want to know how far apart are they in the real world. So what the scale was basically telling us is that on the map, something that is 2 centimeters is really 1 kilometer in the real world. Okay, that's how I switch between the map and the real world. I'm interested in something that's 13 centimeters on the map, and so I want to be able to say 13 centimeters equals some real world thing here, but it's difficult to get from the number 2 to the number 13 in one move. It can be done, but I'm going to suggest you take it down to 1 first of all. That's something you're quite used to. So let's start by dividing both sides by 2. So that's half a kilometer now, or 0.5. So anything on the map that's only 1 centimetre is half a kilometre apart in the real world. And then I'll multiply both sides by 13, because that's how you get from 1 to 13, isn't it? It's times by 13. So there we go. 0.5 times 13. You can use a calculator if you like, but I know that's 6.5 without a calculator. So that's all it is. Suppose there was something on the map that you're interested in that is, I don't know, on the map, it's 5 centimeters apart. And I want to know, well, how far apart would they be in the real world? So you've got your situation that 2 centimeters, this is your scale, is 1 kilometer in the real world. I want this to say 5, but it's difficult to get from 2 to 5 directly. So let's divide both sides by 2, first of all. That gives us that 1 centimeter is half a kilometer. And then I can times both sides by 5 to work out that something that's 5 centimeters on the map is actually 2.5 kilometers in the real world. So I divided by 2, both sides by 2 to get from here to here, and then multiply both sides by 5 to get from here to here. Now I can use the same relationship to go the other way around. So suppose I know that in the real world there's 2 places which are 4 kilometers apart, and I want to know what would that look like on my map. So again, let's just reset the scale. It's 2 centimeters is 1 kilometer in the real world. I want this to say 4 kilometers in the real world, to just get it in the right column, and that's actually quite easy. I don't need to sort of do too much messing about. I can see how you get from 1 to 4 directly. It's just times by 4, so that would be 8 centimeters on the map. Nice, easy peasy. Now you also need to know how scales work when they look like this, when they're given as a ratio. You'll notice that there's no units given in here, and that's because it's not important. What we're saying with the map scale of 1 to 50,000 is that 1 of any unit on the map is actually 50,000 times bigger in the real world. So something that measures 1 centimetre on the map is 50,000 centimetres in the real world. Something that measures 1 foot on the map is actually 50,000 feet in the real world. Something that measures 1 metre on the map is actually 50,000 metres in the real world. So it doesn't matter what units you're using, basically it's saying that the real world is 50,000 times bigger than your map is. So whatever units you use over here, it gets inherited over here. So let's do those examples again that we had earlier, but trying to do it with this version of the scale instead. So we said the distance between Folkestone and Hythe was 13 centimetres on my map, and I want to work out how far apart they are in the real world. So I'm going to put 13 centimetres over on this side, on the map side, and hopefully you can see clearly this time I'm not going to multiply both sides. I'm actually going to multiply it across here. I notice that to get from the number 1 to 50,000, that's just times 50,000. So I'm going to do the same down here. I'm going to multiply 13 by 50,000, and that should tell me how many centimetres the distance between Folkestone and Hythe is in the real world. So I've done nothing more complicated than just type it into my calculator. 13 centimetres times 50,000 is 650,000 centimetres. And that's actually the correct answer. That in the real world, the distance between Folkestone and Hythe is 650,000 centimetres. And although that's correct, it's not really the most sensible units for describing the distance between 2 towns. So that's the right answer, but we now need to make the units a bit more sensible. So you then have to use one of the sort of following situations. These are standard conversions that get you from one type of units to another, and this time we've not got like map on one side and reality on the other side. That's not what's going on. These are just how you switch between the units for the same thing. Sometimes you might need to use a combination of these things. But anyway, we've got the right answer. We've got that in the real world, the distance between Folkestone and Hythe is 650,000 centimetres. Let's convert those units to make them a bit more sensible. If I divide by 100, so knock off 2 zeros, 6500, that would go from centimetres into metres, because you divide centimetres by 100 to get to metres. And then I could turn that into kilometres by dividing by 1,000, because if you divide metres by 1,000, it turns into kilometres. To divide this by 1,000, move the point 3 places, that's 6.5 kilometres. So it's a bit more tricky when the ratio doesn't have the units built in for you. It inherits the units of whatever you measured in. So because I measured with a ruler in centimetres, 13 centimetres, 50,000 times more than that is 650,000 centimetres, and that is the correct sort of final answer, but the book's not going to give that as the answer for the distance between 2 towns. You're going to then have to convert this to some sensible units. Okay, our second example was what if you got two things on the map which are 5 centimetres apart. So let's do that example as well. Our map scale is 1 to 50,000. Things in the real world are actually 50,000 times bigger than they appear on the map. So I measure something on the map which is 5 centimetres. In the real world, therefore, it's 50,000 times bigger than this. So to get from here to here, it's times by 50,000, like we did before. 5 times 50,000 is just 250,000, and 50,000 times 5 centimetres is 250,000 centimetres. So that is the right answer, but that's a bit of a strange unit to use if you're talking about something in the real world. This is quite unwieldy. So let's convert the units. We've sort of finished the question. We've done the scale thing, but let's convert the units now. To turn centimetres into metres, divide by 100. That's knock off a couple of zeros. So that would be 2500, 2,500 metres. And if I divide that by 1,000, I get that into kilometres. So 1, 2, 3, that would be 2.5 kilometres. Something that's 5 centimetres on the map will be 2.5 kilometres in the real world. Okay, so I've got my map scale again, 1 to 50,000. Something that's 4 kilometres in the real world, how would that appear on the map? So this time I'm going from 4 kilometres in the real world to the map. Now notice, to get from here to here, this time it's not times by 50,000, it's divide by 50,000. So to get from the real world to the map, I'm going to divide by the big number. So divide by 50,000. That's going to look a bit strange on my calculator, because if I type in 4 divided by 50,000, I press that, it gives me a fraction first of all. If I press SD, it gives me that next, which is the answer in something we call standard form. So neither of those are that useful to us. But the main reason why it's not that useful is because the units are daft. I'm talking about a map which is not very big. The map fit on my desk earlier, and it seems really silly to talk about how many kilometres is something on the map, because it's going to be nowhere near even 1 kilometre. So let's turn this into more sensible units. It's in kilometres at the moment, but if I multiply by 1,000, I'll be turning that into metres. And now it's a bit more sensible. When I press SD, 0.08 metres, 0.08 metres for my 4 kilometres in the real world. And again, I can make that even more sensible if I multiply by 100, because I can get that into centimetres. So times by 100 is just 8. So it's only 8 centimetres on my map, which is the same answer that we had before. So let's do a couple more examples with a different scale. Now, the map I borrowed from school had the scale 1 to 25,000. Suppose there's 2 points of interest on my map which are 12 centimetres apart. I'd like to work out how far apart they are in the real world. So if this is 12 centimetres here, to get from the map to the real world, I'm just from 1 to 25,000, just multiplying by 25,000. So something that's 12 centimetres on the map is 25,000 times bigger in the real world, and I think that's 300,000. Let's just do that carefully on the calculator. So 25,000 times by 12, yes, is 300,000. That's in centimetres, okay, because 25,000 times bigger than 12 centimetres is 300,000 centimetres. But that's a slightly daft answer to be useful. How far is it from here to there? Oh, you've got to walk 300,000 centimetres. That would be a ridiculous unit to use. So let's turn the centimetres into metres and see if that's any better. Knock a couple of noughts off. That's going to give me, 3,000 metres. And let's turn that into kilometres, maybe divide that by 1,000. That seems a lot more sensible. That something that's 12 centimetres on the map is 3 kilometres in the real world, and that'd be the sort of distance people might walk if they have a nice Sunday afternoon stroll. But it's difficult to imagine what 300,000 centimetres actually looks like. Despite being the correct answer, this is a more sensible answer, and it's definitely the sort of units that will be given when you look up the answer in the back of the book. So one last one then. Suppose something is 7 kilometres in the real world, distance between 2 points is 7 kilometres, and I want to know what would it look like on this map, which is a bit more zoomed in than my first one. So the 7 kilometres is the real life thing, so let's put this over here. And I note that to get from the real world to the map, that is dividing by 25,000. To get from 25,000 to 1, it's divide by 25,000. So let's do that. 7 divided by 25,000 gives me initially this fractional answer, or there's that one, the 2.8 times 10 to the minus 4 answer. So 2.8 times 10 to the minus 4 kilometers on the map. That's just another way of saying 0.00028. So it's like a really small number, basically. It's just another way of saying that. But that's in kilometers. So although it is the right answer, it's a bit daft to talk about, the kilometers when you've got, just something on a map which is small. So let's turn this into more useful units. Let's turn kilometers into meters. We'll do that by multiplying by 100. So do 1,000, isn't it? 1,000 meters in a kilometer, my bad. Multiplied by 1,000. That comes out as 0.28 meters on the map. But still, that's a bit strange to talk about meters. Maps are things you can hold and put on your desk. So maybe centimeters are better. Let's multiply that by 100. And we get the answer 28. So that's about a ruler, isn't it, roughly? It's a bit shorter than a ruler. So 28 centimetres. So therefore, something that is 7 kilometres apart in the real world will appear about a big ruler apart on your zoomed-in map with a scale of 1 to 25,000. I think a summary is in order. To get from the map to reality, you need to multiply by the number in the scale that's not the 1. So let's just say multiply by scale. Okay, but to get from reality to the map, that's divide by the scale. In the questions you are going to do, you will see 2 different exercises. The first exercise will always be going from map to reality, and the second exercise will always be going from reality to map. Don't forget, you will also need to make conversions of units as you go along. Now, it's a tricky topic. You might need me to go over bits and bobs again, and that's absolutely fine. I'll be in the Google Meet, so please pop in if you want me to do a few more with you. I can take you through until you get the hang of it, no problem.